Alright, so I just want to discuss with you again about the circuit that we have here, which is called a car park system. This is just a digital car park system which indicates the number of car park slots available in a car park. If you have a car park in anywhere, it can show you the number of slots that are available. So if you want to park your car, you'll be able to see what is there, if you can go in or you can't. So what you have here now, here we have the 7-segment displays which show the display of what we have. Here we have the ones that display full and the ones that shows the number of spaces available. So we have our VCC source here, and also you have the 2 decoders here, you have 2 counters here, and also we have a latch here, then all gates to control our flow design. How does this thing work? Here this system uses our BCD system, that is a binary coded decimal. We have a counter which is a BCD, synchronous BCD up down counter. It counts from 0 to 9, then from 9 back to 0. So the decoder we count from the first 0 to 9, while the second decoder is cascaded with the first one. The second decoder will be controlled by the first decoder. When the first decoder moves from 0 to 9, after that going back to 0, the second decoder will count 1. Likewise, it goes like that until it gets to 99, which we are counting. So the simple mode of operation here we have, also here we have sensors from the entry and exit of the car park. Here we have the 2 sensors, 2 pulse switches here from the generator here that we are using. So this is just to test our circuit in the lab from this trainer kit. We have here now, we have this 99. This thing is being made as a default for 99. We just use it as to represent. So we want to just say the car park is empty now, and we want to go for, let's say, assume that car is coming into the car park. If any car comes into the car park, the number displayed here will be reduced because this is the number of slots available that is showing to us here. Now see, a car has entered and we have 98 slots available. If another car enter, it will be 97 again. Another one enter. So that is how it keeps on reducing when any car enters into the car park system, into the car park. Then if any point in time we have any car going out of the car park, which is this second sensor, you see it will count up. You have 92 here, cancel up again. So if this say car is going in into the car park again, it will go down, go down, go down, go down. So when the car keeps on coming into the car park system, what we have at the output, it will start reducing also. So until it reduces to 0, 0. So 0, 0 indicates that we have 100 cars in the car park, so which will display full here, just to show anybody from the other side that is coming into the car park that there is no space for him or her to park his car in the car park. So you see we have 7, 6, 5, 4, 3, 2, 0. When you have 0, 0 here now, you have full display, as you can see. So this indicates there is no free slots available, so anybody coming in can go and look for another place to park car. So also from 0, 0 here, if at any point in time we have cars going out of the car park, you have 1 again. So we have 1 slot free, 2 slots free, 3, 4, 5, 6, so and so on until it gets to 99 again. So that is how it keeps on going in, going up, going down. So as car keeps on coming in, coming out. So the number, what do we use here, the components here, this is just a simple circuit. We use, as I said before, we use 2 counters as our first thing. We have first 2 sensors, one at the entry, one at the exit. Then to control our sensors, we have a latch, which is SR latch, which control to get 0 and 1 according to working system of a latch. So from there we have our output from the latch down to the counters. We have counter which we use here, which is 74LS190, 2 counters that we use. Then we use 2 decoders, each 1 decoder each for each counter. The decoder that we use here is 74LS48 decoder that we use here. It has a 5-volt control, and apart from that also, as I said, we use SR latch before. Then we use all gates, NOR gates. The NOR gate is just to control our pulse going into the counter, that is the pulses from the exit or entry of the car park. So it will just give us the clock pulse in order to activate counter to move up and down. So this is just a simple up and down counter system. That is a digital car park counting system. We also have some limiting resistors here just to limit the number of, to limit the current going into the 7-segment display. This will control the illumination of this 7-segment display, and it will help us to protect these 7 segments from being burnt away. So that's just what we have here. It's a simple design which anyone can do and anyone can design. So see you in the next edition. Thanks.